This is the first podcast for the reading of Chapter 5, and in Chapter 5 we're introduced with box plots. And to me, a box plot is a way of visually displaying the 5-number summary, okay, the max, the min, the quartiles, median. Now, one thing to always remember about box plots is that it's separated into intervals that are 1/4 of your data. Okay, which means that if it's a long interval, there is less data there. Okay, if it's a short interval, there's lots of data there. So keep that in mind about box plots. Okay, the book explains exactly how to create a box plot. I do want you to be aware of how to draw a box plot by hand. Finding the quartiles and the median and the drawing lines, the whiskers. Now, in here, we get a mathematical definition of what an outlier is, or at least a good rule of thumb. Okay, and that rule of thumb is if it's more than 1.5 times the IQR above Q3, or less than 1.5 times the IQR below Q1, that's an outlier. It's a good rule of thumb. I still like the idea of looking at the data and seeing why is this point so high or so low. There could be a mistake there could be a different reason there, but that's a good rule of thumb that's used by a lot of statisticians. Okay. Also notice that at the very bottom here, we get the definition of a far outlier, which if a data value is further than 3 IQRs from the quartiles. Okay, here's a TI tip as far as how to make a box plot on your calculator. It's not too difficult as you're just simply selecting a different type here than the histogram. It's the one that looks like a box plot that has the dots for the outliers. Okay, when comparing distribution, this is a huge idea. Okay, you will compare the modes, the symmetry, and the outliers or the gaps. Okay, the same criteria you use when describing a distribution is the same criteria you will use when you are comparing distributions. Okay, the most common place that I see box plots used in research and other places are when you are comparing 3 or more distributions. Is the most common place. I've never seen a box plot by itself looking at one distribution. They always use histograms in that case. Okay, if you're comparing multiple distributions, you always use box plots. Okay, now if you're asked to compare box plots, this is not a set in stone list, but the things that I think through is how do the medians change? How are the IQR? How do the IQRs compare? The outliers, are there some that are, really that are disjoint, that are really high or really low? So those are things to think about as you're comparing distributions using box plots. Okay, the last idea about outliers, I discussed this a little bit ago, but when you have an outlier or a point that's really high or really low, you have to stop and ask yourself, why is that point so high or low? Is it a mistake? If it's a mistake, you can throw or correct the mistake. Okay, if possible. So did the person fill out the wrong box? Did you type in the number wrong? If it was a mistake, then correct the mistake and still use the point. If it can't be corrected, then you can throw that point out. But make sure you note that in the conclusion of your analysis. Now, is that outlier caused by that point being somehow different? The nature of that person or that point is somehow different than the others. If so, you may or may not want to throw it out. Okay. If you keep it in, you may want to run your analysis before and after. Or if you throw it out, make sure you note that in your analysis and you have to justify why you're throwing it out. Okay. The third reason is that point just happens to be really high or really low. In that case, you must keep it in your analysis. Okay. This was the first reading podcast for Chapter 5.